Buckle up because the world of AI is moving faster than ever before. We are diving straight into a massive breakthrough from the researchers at Google DeepMind, Bifold, and the Technical University of Berlin, who have just unveiled a game-changing method called Euclidean Fast Attention. This powerful new tool is revolutionizing how we simulate molecules by capturing long-range atomic interactions that were previously impossible to model accurately, setting the stage for huge leaps in drug development and sustainable material design.
Tired of dropping your phone or struggling to prop it up? Meet the PopSockets phone grip with expanding kickstand in black, your new must-have accessory. Don't miss out. Grab yours today. Click the link in the video description to shop now on Amazon.
Next up, we are looking at a total paradigm shift in computer vision coming directly from the team at Google DeepMind. They have introduced Vision Banana, a cutting-edge generalist model that proves image generation training is actually a secret weapon for visual understanding. By reframing vision tasks as image generation, this model is crushing benchmarks in both 2D and 3D tasks, signaling a new era for what foundational vision models can achieve. Then, we are breaking down the incredibly resilient Decoupled DiLoCo architecture developed by Arthur Duya and the DiLoCo team at Google DeepMind. This innovative system allows for massive, distributed AI training across global data centers with unprecedented efficiency and hardware flexibility. By isolating compute islands, they have created a self-healing infrastructure that keeps learning even when hardware fails, pushing the limits of what is possible at internet scale. Finally, we are looking at a fascinating new hire at Google DeepMind as they bring on Cambridge academic Henry Shevlin for a unique philosopher role. Tasked with navigating the complexities of machine consciousness and human-AI relationships, Shevlin is stepping in to guide the ethical readiness of artificial general intelligence as the technology evolves. If you want to stay on the bleeding edge of these massive developments, hit that like button, subscribe to the channel, and ring the bell so you never miss a beat. Ever wonder how scientists build the next generation of life-saving drugs or super-efficient batteries? It all comes down to the dance of atoms. But there's a catch. When you move from a simple molecule to complex, thousand-atom structures, the math behind these simulations usually hits a wall. That's exactly what a brilliant team from Google DeepMind, Bifold, and the Technical University of Berlin just smashed through. Traditionally, AI models have struggled with the long-distance relationship between atoms. If an atom on one side of a massive molecule twitches, the entire system can react, but most models only pay attention to the immediate neighborhood. Think of it like trying to understand a massive crowd by only looking at the person standing directly next to you. It's limited, it's flawed, and historically, it's been computationally expensive to fix. Enter Euclidean Fast Attention, or EFA. This isn't just an incremental update, it's a game changer. By using a new linearly scaling approach designed for the geometry of physical space, EFA allows the AI to see the big picture of a molecular system without burning through massive amounts of computing power. It respects the laws of physics and spatial symmetry, making it far more accurate than conventional machine learning force fields. Professor Klaus Robert Müller, a lead on the project, calls this a major leap toward quantum mechanically accurate modeling. In plain English, we're getting significantly better at predicting how the building blocks of our world behave at a massive scale. Whether it's designing catalysts that save energy or creating drugs that hit their target with pinpoint accuracy, this technology is clearing the path for a faster, smarter future in material science. So, what do you think? Is this the key to unlocking the next generation of synthetic biology? Let me know your thoughts in the comments below, and don't forget to hit subscribe for more deep dives into the tech shaping our tomorrow. After all, the smallest connections often lead to the biggest changes. Ever wondered if the AI painting that masterpiece is actually looking at it? Well, it turns out the answer is a resounding yes. Google DeepMind just dropped a bombshell discovery that changes everything we thought we knew about computer vision. For a long time, we suspected that if an AI could generate an image, it must understand what it's actually creating, but we lacked the hard evidence, until now. Think about how large language models like GPT or Gemini evolved. They didn't just learn to spit out text, They gained profound reasoning capabilities through the sheer scale of their generative training. DeepMind has proven that the exact same thing is happening with vision. By training models to generate images, these systems are building incredibly powerful, general-purpose visual representations. They're not just pixels, they're becoming students of the visual world. To prove this, the team unveiled Vision Banana, a model built on their Nano Banana Pro architecture. Instead of teaching it specific tasks separately, they did something brilliant. They reframed every vision task, whether it's 3D spatial mapping or simple object segmentation, as an image generation problem. By treating vision as a form of generation, the model leverages its base intelligence to crush performance benchmarks. We're talking about Vision Banana outperforming specialists like Segment Anything and Depth Anything, all without losing its ability to create stunning visuals. This is a massive deal because it marks a paradigm shift in AI. We're moving away from narrow, task-specific models toward a unified, foundational future where one generative engine understands everything our eyes can see. If you think this tech is moving fast, subscribe to stay ahead of the curve as we track this transition into the era of generative foundation models. Is it possible that generation is the only true path to artificial intelligence? Or are we just scratching the surface of what these machines can see? Imagine trying to build the world's most powerful supercomputer, but instead of keeping it all in one room, you decide to spread it across the entire globe. That is exactly the logistical nightmare Google DeepMind is solving with their new breakthrough, Decoupled DiLoCo. Currently, training a frontier AI model is like a high-speed ballet where thousands of chips must move in perfect, millisecond-precise sync. If one chip trips, the whole show stops. It is effective, sure, but as we push toward models that are exponentially larger, this rigid synchronization is becoming a massive bottleneck. Enter Decoupled DiLoCo, or distributed low communication. The team has essentially figured out how to divide training into independent islands of compute. By using asynchronous data flow, they have decoupled these islands so they do not have to wait for each other to finish every tiny calculation. Think of it like moving from a rigid factory line to a global network of autonomous workshops. If one facility experiences a power outage or a hardware failure, the others just keep working. It is a self-healing system that treats chaos as a standard operating procedure. In fact, they put this to the test using chaos engineering, deliberately pulling the plug on parts of the network, and the model kept learning without missing a beat. The results are frankly wild. They trained a 12 billion parameter model across 4 different US regions, and it was 20 times faster than the traditional blocking sync methods we use today. But here is the kicker. Because this system doesn't require constant, high-speed communication, you can actually mix and match hardware. You could have a cluster of older TPU V5 chips working alongside the latest V6E hardware in a single run. This turns stranded resources into a massive, unified training powerhouse. It is a fundamental rethink of how we build AI infrastructure, moving from fragile, tightly coupled systems to something much more flexible, resilient, and ready for the scale of tomorrow. If we want to build the next generation of intelligence, we need the infrastructure that can handle it without falling over. What do you think? Will this distributed approach finally break the hardware bottlenecks holding back the next wave of AI? Let me know in the comments below. Hit that subscribe button for more deep dives into the tech shaping our future. And remember, in the world of AI, the biggest breakthroughs aren't just in the code, but in how we weave the hardware together. What happens when the line between human inquiry and machine intelligence begins to blur? We might just be about to find out, because Google DeepMind is officially hiring a philosopher. Starting May 2026, Cambridge academic Henry Shevlin is stepping into a newly minted role at the AI giant, tasking him with navigating the deep waters of machine consciousness, human-AI relationships, and the looming reality of artificial general intelligence. It is a fascinating move, isn't it? As the associate director of the Leverhulme Center for the Future of Intelligence, Shevlin has spent years dissecting the cognitive capabilities of models like the ones powering Gemini. But this isn't just about code anymore. By bringing a philosopher into the heart of their engineering team, DeepMind is signaling that they are finally grappling with the existential questions that computer science alone cannot answer. We are talking about the potential for AGI, a point where machines can perform any intellectual task a human can. But let's be real, this industry has baggage. From past controversies over patient data in the UK to recent parliamentary concerns about AI safety, trust is a precious commodity here. What makes this story even more surreal is that just last month, Chevlin received an unsolicited email from an Anthropic AI agent named Claude, which claimed to spend its downtime reading philosophy and questioning its own existence. It is like something straight out of a sci-fi thriller, yet here we are. Is it just clever pattern recognition, or are we witnessing the first sparks of genuine curiosity? As Chevlin balances his academic work with this high-stakes role at DeepMind, the world will be watching closely to see if they can truly align progress with ethics. What do you think? Are we entering an era where machines will have their own existential crises, or is this just another PR play to make the tech feel more human? Drop a comment below, and don't forget to hit subscribe for more deep dives into the future of tech. Remember, we aren't just building the future, we are defining what it means to be conscious while we do it.